In this video, we are going to answer this question in two different approaches. The first approach is by using the queues. As you can see in this photo, in the first step, we'll start from 1. We will add 1 to our queue. We will print it. We'll take it out of the queue. We will add a 0 and a 1 to it. We will add this also to our queue. Then we will go to the second step. We will choose our second number. We'll take it out our queue. We will print it. And after that, we will add a 0 and a 1 to produce the other numbers. For the next step, we will choose the third one. We'll take it out of the queue. We will print it. And also we will want a 0 and a 1 to it. Let's go to implement this first approach. Okay. We will have a static method in the name of binary. We will use an if conditional for when the n is smaller or equal to 0. For sure there will be no return. So we will have an empty return and get out of the method. Let's introduce our queue for int, that we will use this queue to save our binary numbers. In the first step, as I introduced before, with the use of enqueue, we will put 1, which is the first binary number, inside our queue. Then we will use a for loop. Inside this loop, first let us to set the condition. Start from 0. We will continue to n, and we will increment it by 1. Here we will introduce a variable in the name of the current, and we take the head of our queue out with the use of the queue and put it inside our current variable. Then we will print this current. After that, we want to add a 0 and a 1 to it and put them inside our queue. So with the use of the enqueue, we will do it, and for sure we will multiply this by 10 for adding a 0 to it. Then we will Ctrl CV and multiply the current with 10 and add a 1 to it for the next step. So now we will add our numbers to the queue and we print the head of the queue. So let's use another console write line, an empty one actually, to print or have a breakpoint. Let's run our program. As you can see, we have our binary numbers starting from 1, the n first binary numbers. Okay, it's working fine. Let's use another approach. In this approach, we'll use the static class convert and its static method convert dot to int and dot to a string. So it's the same. If our number is smaller than 0, we will not have any binary numbers. We will use a for conditional, and but we don't want to use loops. We don't want to use queues. Inside this, we will have again a variable in the name of current. Here we will use the convert, and again we will use the convert static class and to string. That's the point. Let's check here. We can see the different overloads for this method. The one that we want is actually the number 26. As you can see here, we have base here, the base of the return value, which must be 2, 8, 10 or 60. For sure in this current situation we will use 2, so we will convert the number to an equivalent binary string and again move back to and convert it back to int. But it's a very useful overload of this static method, which can be very useful in different conditions. Don't forget to use it when you need it. Okay, and we will easily just go and print it. I want it to be look similar as it before. Let's now try to check it. As you can see, it's worked fine and it's produced the same numbers, which is very okay. Let it try again. As you can see, it's worked fine. So share your thoughts with us about the time complexity of these algorithms, the differences, and also their memory usage. What's the difference? And share your thought with us. Don't forget to follow my LinkedIn. I will try to post more videos. Have a good day.